Here we're going to look at question 24 from the NSAA 2018 paper. So in this question, we're told that we have a metal rod which has a temperature of one end a temperature of T1, and the other end has a temperature of T2, where T1 is greater than T2. So we're also told the cross-sectional area of our rod is going to be A, and that the rod has a length L. So the question asks us to do is to find how the rate of heat flow, which we're calling P, is related to each of these variables. So if you'd like to have a go at this question yourself, then please just pause the video now. Otherwise, let's have a go at it. Okay, so let's first think about the temperature. Now you can imagine with a metal rod that if we had two ends of our rod at extremely different temperatures, so one end was really hot and one end was really cold, then the rate of heat flow, would be quite rapid, right? We'd expect the hot thing to sort of really transfer a lot of heat quite quickly to the cold end. Whereas if we had two temperatures the same, then we'd expect absolutely no heat flow whatsoever. So what this tells us is really that we're looking for the difference in heat flow, and particularly that the bigger the difference in temperatures, the larger the rate of heat flow. So what this means is that P is going to be proportional to the difference between our two temperatures. If it was inversely to the difference, then that would mean that a really large difference would mean a really small heat flow. And similarly, if we were to add these rather than take them away, then two ends which were the same temperature would have a non-zero heat flow, so heat would somehow be flowing from one end to the other, even though the two ends are the same temperature. So we're actually looking for P to be proportional to the difference. Next up, we can think about the area of our rod. So one nice way to do this is to think about two rods next to each other. Because in this case, we're going to have double the area. So if we just had one rod with another rod next to it, both with with one end being a temperature T1, the other end with a temperature being T2, then we would expect double the amount of heat to be flowing. Because one rod would be transferring heat at the rate it was before, and the rod would be transferring the same amount of heat. So doubling the area is doubling the amount of heat flow, and therefore the rate of heat flow. So we would expect our rate of heat flow to be proportional to our area. If it was going to be inversely proportional, then we would expect the opposite. So a really large area or lots and lots of rods would mean a really small amount of heat flow, which wouldn't make any sense. So now that we've thought about area, we can move on to length. And now to do this, what you can do is imagine a rod of about double the length. So if you were to do this, then you would expect that halfway down, the temperature would be halfway between the two temperatures. In which case, the difference in temperatures is going to be a bit smaller. It's going to be halved. So the rate of heat flow is going to be smaller. Alternatively, you could think about the fact that the temperatures are then much further away. So the distance between temperatures, is much greater. And so the rate of heat flow isn't going to be as rapid. It's not going to be quite as quick. So for example, if you were to imagine a really small rod which had one end which was 1,000 degrees Kelvin, another end which was about 0 degrees Kelvin, and it was just a tiny little rod, then you'd expect there to be a really rapid rate of heat flow. Whereas if that rod was like a kilometre long, you wouldn't expect the heat to fly down the rod, would you? So with that in mind, then what we can say is that this rate of heat flow is inversely proportional to the length of our rod L. So in total, what we're saying is that the rate of heat flow is proportional to the area multiplied by the difference in temperatures and inversely proportional to the length of our rod. So this is going to correspond with answer C given in the question. Now this question does seem quite odd in that it really is just a lot of guesswork and thinking, but there's actually no other way really of doing this question without just knowing this formula. So sometimes using a bit of sort of common sense is actually a really good idea with these questions.